Hi guys, so here we're going to talk about one of my favorite topics in thermodynamics. It's the second law of thermodynamics. So you're going to need your notes and pen and paper. So we're talking about the second law, some examples of that second law, which is called entropy, dealing with phase changes and moles. So the second law of thermodynamics is that all systems in nature goes towards high entropy. And entropy has the symbol of S, capital S. And it's just the measure of disorder. So think about your room right now. And it takes some energy in order for it to actually get clean, right? So most of the time, at least in my case, I understood, things are in disorder. And that's actually, again, entropy. So we call that a positive delta S. So when things are at a lot of disorder, it's a positive delta S. And we call that thermodynamically favored or spontaneous, meaning the reaction is actually going to occur. So, it doesn't really take very much effort for our rooms to become a disaster, kind of like this, right? Hopefully it doesn't look that bad. So, an example of this in chemistry is a decomposition reaction. Here we have carbonic acid. It's one compound. It has carbon, 3 oxygens, 2 hydrogens, and that produces water and carbon dioxide. So here you're taking this big uniform compound and breaking it up into smaller compounds. So a decomposition reaction is an example of something that has high entropy, because you start off with something that, again, one compound, and you break it up into smaller compounds. When we deal with states of matter, entropy, pretty much gases have the most amount of entropy. They have the most amount of disorder. Those particles are flying all over the place. They're moving constantly. Whereas in a solid, all the way down here at the bottom, we see that they're actually just going to be uniform, they're tightly packed together, they don't take up very much space. So solids have low delta S's, or entropy. Gases have high delta S's, or high entropy. So we see this here with a block of ice. So a block of ice, it's solid, and when heat is added to it, it becomes a puddle of water, it becomes liquid. So we have a higher amount of delta S in the puddle of water than we do the block of ice. So the delta S will increase. If we go back through and freeze that puddle of water into ice, that delta S will actually decrease, because then that puddle of water is becoming more uniform into that block of ice. So again, when we go from a solid to a liquid, we have a high delta S. When we go from a liquid to a solid, we have a low delta S, or it decreases. When you're given a chemical equation, and the first thing you want to do is check to see what type of reaction it is. In this case, it's a decomposition reaction. We start out with one particle, ends up with smaller particles. Another thing you want to look at is the states of matter. So each of these they're all aqueous. So, if we went from a solid to a liquid, yeah, we would know that the entropy would increase. If we went from a gas to a solid, we know the entropy would decrease. But in this case, they're all going to be the same states of matter. So in this case, you actually have to look at which side has more moles. So since it's a decomposition reaction, we start out with 1 mole, because there's a coefficient of 1 right in front. And then at the end, if we kind of divide this up, we have a mole of H plus and a mole of acetate. So there ends up being 2 moles of particles on the right-hand side. So 1 mole came from here. We add that to a mole from over here, and again, it's because of the coefficients. There's only 1 really listed right there. So since we went from a 1 to 2, we increased the amount of entropy. So we increased the amount of delta S. To quickly summarize, entropy is a measure of disorder. We use delta S as a symbol for that. A positive delta S is going to be thermodynamically favored, meaning it's going to be more spontaneous. It will happen without too much input of energy. Entropy will decrease when you go from a gas to a liquid or aqueous to a solid, and entropy will increase when you go from a solid to a liquid or an aqueous to a gas. And if you're given a chemical equation and there's all the same states of matter, look at the number of moles, or the coefficients in the front. If you go from a side that has fewer moles to a side that has, the products have more moles, then you know that you've increased the entropy. All right? So hopefully you have a good day. Take care. Bye.